Our next proposition is prove that the number of edges in a bipartite graph when n vertices with n vertices is less than or equal to this equation. So n is the number of vertices, and the proposition says that for any bipartite graph, the number of edges will not exceed this number. How we are going to prove this problem? So this is the proof now. First, we need to define let n be the number of vertices of a bipartite graph and V1 and V2 are the two set of vertices of G. So what we will do next, we need to define the cardinality of each of them. So we say assume that the size of the first set is equal to x, then what will be the size of the second set? Then the size of the second set will be n minus x. And the maximum edges and the maximum edges is obtained when we multiply x by n minus x. So I will just going to call it E equal to x times n minus x. And remember, this is for complete bipartite graph. Okay? And here maybe I should write a note here, and we will call it Emax. So the maximum number of edges you can get when V1 of size x and V2 of size n minus x, then we have Emax, which is the maximum number of edges we can get for these two sets. Next. Now, what is the value of x so that Emax gives me the maximum? Maybe you should demonstrate by the following example. Imagine here, see, here we have x. If this is x, and here we have n minus x, and here we will have Emax. So we will draw a table. So we will make a table for each of these. Now, if x is 1, if x is 2, if x is 3, 4, 5, and 6, what will be the value of n? As an example, suppose n is equal to 6. So we have a graph of 6 vertices, and we would like to see if it is a bipartite graph, and we partition the sets into x and n minus x. What is the value of x that gives me the largest number of edges? So let us go over these values of x. Now n is 6, 6 minus 1 is 5, 6 minus 2 is 4, 3, 2, 1, and 0. And now when you multiply them, here you will get 5, and here you will get 8, here you will get 9, here you will get 8, here you will get 5, and here you will get 0. So notice now, where is the maximum value for this function? The maximum value is 9. And what is the value of x? The value of x is 3. So what is 3 related to n? In fact, you can look at it as if it is half. So if you have V1 vertices and x vertices and n minus x vertices, the maximum number of edges you can get when you multiply x by n minus x is that if you divide the two sets into half. Half of the graph, half of the vertices in one set, V1, and the other half will be in V2. Then here you will get the maximum. You can also find this from calculus, if you remember calculus. Now in calculus, let f of x is equal to x times n minus x. Remember that this equation is for the complete bipartite graph. Now, in calculus, if you have a function, how to find its minimal or local minimal and local maximal? You take the derivative of f of x and make it equal to 0. In other words, what is the value of x such that f of x is the maximum? So you take derivative of f of x, make it equal to 0. So you will have, so this is f of x is equal to x n minus x squared. So the derivative of f of x will be equal to n minus 2x. Make it equal to 0. So from here, n is equal to x, so x is equal to half n. So this tells you that if you partition the two sets half, then you will get the maximum value of the multiplication of x multiplied by n minus x. So we have E max equal to x multiplied by n minus x. Now substitute for x equal to n over 2. So we will have n over 2, n minus n over 2. And this will be equal to n over 2. Now n minus half. So it will be half. So it will be n over 2. And this will be equal to n squared multiplied by 4. So therefore, any bipartite graph the number of edges will be less than or equal to E max. And therefore, we say that the number of edges in here is less than or equal to n squared over 4, and this completes the proof.